Okay, in this video I wanted to just review a bunch of things we've been talking about in terms of polars and limits and derivatives. So, graphing 1 plus 3 sine theta. So I want to kind of handle this like we've been, where we are going to start it with our kind of doing it by hand, but then go to our calculator to finish it off and make sure that we are set with that. So we've got thetas, we've got r's. I'm going to pick some just kind of easy thetas, okay? So let's start with 0. So recall that the sine of 0 is 0, so we end up with 1 plus 0, so r is just 1. So when we are at 0, r is 1. So maybe I'll change color so we can see a little better right there. All right, the next maybe easy one would be pi over 6, because pi over 6... the sine of pi over 6 is 1/2, so you've got 3 times 1/2, so 3 halves are 1.5. 1 plus 1.5 is 2.5, so 5 halves are 2.5. So going on that pi over 6 line, going out 2.5 units, kind of towards here. The next, after this, you can start doing like the pi over 4, the pi over 3, but those aren't really nice values for sine because, it's the sine of pi over 4 is square root of 2 over 2. We could certainly use our calculator to do that. The sine of pi over 3 is the square root of 3 over 2. And again, we could use our calculator and get a decimal approximation for that, but I'm actually just going to go to pi over 2 because the sine of pi over 2 is 1. So this just ends up being 1 plus 3. So pi over 2, this is going to be 4. So it's right up here. So it actually kind of looks like that. Okay, and then we can continue. We can, do like 5 pi over 6, because that's going to be another nice value. And it remains, sine of pi over 6 is positive, or 5 pi over 6, because sine measures y values, and y is positive in that quadrant at 5 pi over 6. So we would again end up with that 5 halves, or 2.5. And if we went to pi, the sine of pi is 0, so this would be 1. Now, let's fill those two in. So we're kind of coming back around like this. Now, I just want to finish up with a couple more. We got like 7 pi over 6. Of course, any of the pi over 6s are going to be okay. And let's do 3 pi over 2. Now, 7 pi over 6, this is where sine is going to actually be a negative value. So it's going to be sine of 7 pi over 6 is going to be negative 1/2. So it ends up being 1 plus negative 1.5. This is actually going to be negative 1/2. So even though you're out along this line of 7 pi over 6, recall that a negative r value means you go backwards. So it actually is going to be, if I can read my graph here, it's going to be right in here. Okay. Now the 3 pi over 2, the sine of 3 pi over 2 is negative 1. So this ends up being 1 plus negative 3. This ends up being negative 2. So again, even though you're on this 3 pi over 2 angle, you've got a negative r value, so you come back up here. So this is how, and the reason I chose this one, this is how you start creating those inner loops. It's going to go like that. Okay, let me graph this with the calculator quick and verify what we see. All right, you can see here I've put it into my calculator. I want you to notice I'm kind of highlighting the blinking thing, that I've changed that to be that ball with tail. And remember, what that does is kind of slow the graphing down a little bit so that I can actually see it be traced. So when I hit graph, there it is. Now some quick derivative review. None of these should be that scary to you. You'll see here right off the bat, we've got a little product rule. I always like to think about, that we have 2 two functions. So there's the first one. There's the second one. So my derivative first times derivative of the second. The second would require a little chain rule. So it would do like that. Plus the second times derivative of the first. You could certainly do some factoring here. You might see that on the AP exam. Maybe they factor in e to the 5x out. I would accept that answer that you have right there. All right, next, let's just begin by rewriting this. Whenever you're going to do calculus, I would recommend using exponents instead of roots. So now, let's use some chain rule. Okay, we're going to treat that inner function, this thing right here, we're just, we're going to leave that alone. So we're going to bring the 1/2 out front. Leave the inside. Now it's to the negative 1/2. And then multiply by the derivative of the inside. Make sure to use parentheses there, because you don't want to just have it look like it's multiplying by the 12x with a +4 off at the end. Okay. So if we wanted to simplify that, well, we've got this root now on the bottom. And 1/2 times 12x plus 4, we could, we certainly could just write a 2 in the denominator, but this actually could simplify pretty nice to be 6x plus 2, like that. Okay. I'm going to work my way kind of around, because actually that sine squared is actually the hardest one here. I know it maybe doesn't look like it, but I'm going to end with that. Got our two functions here. Going to need some product rule, maybe a little chain rule as well. So first times derivative of the second. Derivative of tangent, recall, is secant. So we're going to have secant squared, excuse me, 2x. And then multiplied by the derivative of the inside. All right, now I'm going to spill down a level here. And then we're going to have second times derivative of the first. Okay, again, you could clean this up a little bit, maybe do some factoring, but I'm going to leave it. All right, finally, and I know this one doesn't maybe look that scary, but I wanted to just remind you, we already said whenever you see an exponent, a root, you should rewrite it with an exponent. When you see trig functions or logarithmic functions with a power kind of written as you see here, I would right away rewrite it to do calculus on it like that. And now it's much more obvious you're going to need chain rule. Okay, so we're actually going to need some double chain rule. I'm going to write up here. Okay, so again, we're treating the sine of 8x as our inside function. So I'm going to bring that 2 out front. Leave the inside alone, so sine of 8x. To the first, and then multiplied by the derivative of the inside, which would be the cosine of 8x. Oops. Cosine of 8x, and then multiplied by the derivative of 8x, which would be 8. Okay, so again, when you see those trig functions to exponents, I would just right away rewrite it so you remind yourself you're going to need chain rule. Okay, a little bit of a limit review. First thing you should always try is just plugging in the number, right? Let's see if it works. 2 times 2 squared is 8. Minus 7 is 1. 1/4. Perfect. Okay. Next, plugging in -5. Now you should notice right away, yeah, this is a problem. Making the bottom 0 is not enough to say it's indeterminate and use L'Hopital. We have to check the top. So let's say 25 plus -40 is -15 plus 15. So it is 0. So we can use L'Hopital's rule here. Just a reminder, in using L'Hopital's rule, if I can maybe just kind of put my work down here, to justify using L'Hopital's rule, there are lots of ways you can write this, but one nice way is you can say the limit as x approaches -5 of x squared plus 8x plus 15 is equal to 0. And the limit as x approaches -5 of x plus 5 is equal to 0. So then you can say you get to use L'Hopital's rule. Now, the reason you should not write on your paper 0 over 0 is because that is indeterminate. That does not exist. So that's one of the things when you grade an AP exam, and I actually graded a question just this last year, doing L'Hopital's rule was worth 3 points, doing it correctly. If you wrote this thing, you wrote this, and then you wrote equals 0 over 0, the most you could get was 1 out of the 3. The minute you did this, and then did L'Hopital, so you said, and I'm sorry, I don't have a lot of room, so, you should then say, okay, well, the old limit equals the new limit. So remember, same x, but then you do the derivative of the top, derivative of the bottom, you plug in -5 and you get -2. Well, then you got all the points. But you have to say something about the top and bottom going to 0 and not writing 0 over 0. But there were other ways to do it. Some students put like arrows. They said like this is going to 0. This is going to 0. They got credit for that. As long as you don't write 0 divided by 0 and you say something about the top and the bottom separately, then you're good. Okay. Going to this next problem, limit as x approaches 0, sine of 0 is 0, 8 times 0. So just for the sake of time and space, I hope you'll forgive, I'm going to do we're going to almost treat this like it was a multiple choice question. You certainly should repeat this process. You should write that the top is going to 0, the bottom is going to 0, and then you should perform L'Hopital's rule by rewriting your new limit statement like this. Okay. I'm going to just say, okay, derivative is 8. Derivative is 4 cosine of 4x. You plug in 0. The cosine of 0 is 1, so this is just 1/2. Okay. Here, you plug in 3. Top is 0. Remember, the top being 0, that might mean the limit is 0. It's very dependent on the bottom. The only time you have to do L'Hopital is when both the top and bottom are 0. So 9 minus 30. Bottom is 0 as well. So again, you should go through this process. For the sake of time and space, I'm not going to model it great, but please be aware of that. The derivative of the top, derivative of the bottom. Plug in 3, we get 6 on the top. We get -4 on the bottom, so -3/2. Okay, coming here, obviously we're going to get 0 on top and bottom. Again, you can put like arrows to 0, arrow to 0 or something, but you just can't write 0 over 0. So derivative is 1, 18x squared minus 8x plus 5. So plugging in 0 again, derivative is going to be 5. And finally, this last one, I plug in 1, I get 4 divided by 0. That, then the limit does not exist. What's happening there is a vertical asymptote. Okay, and that's why the limit doesn't exist. If the numerator works and the denominator is 0, that means it was a vertical asymptote. And finally, just a little review of these graphs. Get the right thing to grab that. All right, f of -1. So this is just saying what's the value of the function at -1. The value of the function is -1. Now, what is f of 1? F of 1 is 2. And what's f of 5? Well, that is, the actual value is 3. Now the limit as x approaches -1. Okay, so you'll notice here, we're approaching -1. Both sides is approaching 0. Doesn't matter if that's not the value. we'll deal with that when we get to continuity. Okay. Now the limit as we approach 1 from the negative side. So approaching 1 from the negative side, well, the limit is 2. Approaching 1 from the positive side, going to 4. And that's how we know then that that limit doesn't exist, because it's not approaching the same thing. 5 from the positive side, coming at 5 from the positive side is 1, and from the negative side is 3.